Question 8, a really complex question. It looks ugly. It's, what is it? Given this function, find the gradient of the tangent at x equals 0. So what have we got? We've got a product rule. It's this function of x multiplied by this function of x. But you've got a chain rule again in there as well. So you've got the product rule with a chain rule included. So we're going to have to use both these rules. Remember, what is the product rule? It's the bottom back term, y equals UV, ultraviolet. Then it's violet times the derivative of ultra plus ultra times the derivative of violet. So that's the way I remember it. But it's the back term times the derivative of the front plus the front term times the derivative of the back. And it looks messy. We're just going to take our time. So what have we got here? Move this up a bit. To y dx equals the back term times the derivative of the front, which is 12x squared. And all I've done is written that back term, the v times the derivative of u plus u. Now, this is where we've got the times the derivative of v. So all we do is do the chain rule here. 5 outside of 3x squared plus 1 to the power of 4. This is exactly what I've got here. 5 outside of 3x squared plus 1 to the power of 4. And what do we have to, where did this 6x come from? We've got to multiply it by the derivative of what's inside the bracket. What is the derivative of this? 6x. Okay, now we could simplify this. It looks fairly ugly though. Or we could just substitute. We want the gradient at x equals 0. So we can just substitute x equals 0. Instead of simplifying all this, what's this going to be? 3 0 squared is 0. So this bracket is going to be 1. 1 to the power of 5. The nice thing is this 12 times 0 squared is going to be 0. And 0 times anything is 0. So this becomes 0. Exactly the same thing happens here. This, when we put x equals 0 in, becomes 0. So you're going to get 0 times whatever is in this bracket. Doesn't really matter, because 0 times whatever's in this bracket is going to give us 0 as well. The 5 doesn't change. This becomes 0 plus 1 times 6 times 0. So this is what we get. So although it looked tough, again, instead of trying to simplify this down to something, even if this was x equals 1, find the gradient of tangent x equals 1, it may have been nicer just to put x equals 1 into your calculator here. 3 times 1 squared is 1, plus 4, plus 1 is 4 to the power of 5. It gets a big number. And then you've got to times that massive number by whatever this becomes, 12, etc., etc. So sometimes you've just got to be wary. Yep, it would be nice to simplify this, but to answer this question, we actually don't have to. We can just substitute x equals 0 in. So hopefully that's taken you through a few little ideas about this basic differentiation. You really need to be on top of it because it comes back so much in the HSC. Like this question 6 up here, where you had the sine and the causes come back in, because we actually do that, this, and understanding that this is a product rule. This is one function of x times another function of x. And it happens with the logs and exponentials as well. Things like x log x, that is a product rule, x times log x. So you really need to work on this and make sure you get it right. Anyway, thanks.